Hi everyone. So today we will be reviewing for your test on Unit 6. On questions 1 through 4, sorry there's a little typo here, should be 1 through 4, we're asked to simplify each of these radicals completely. So it would probably be a good idea if you had your toolbox handy, so you had your list of perfect squares to refer to. On number 1, when you look at the square root of 136, notice that it's not a perfect square, so you want to find a perfect square that divides into it. All right, as a general rule of thumb, if it's an even number, you want to try dividing by 4. And when we do that on this one, we get 4 times 34. And it turns out that 4 is the largest perfect square that divides into 136. So take the square root of 4, and you end up with a 2. So that 2 comes out in front of the radical, and you're left with 34 inside. So final answer is 2 square root of 34. On number 2, we have 6 times the square root of 75. So that 6 is going to be multiplied by whatever we bring out in front of the radical. Now 75 has a perfect square that divides into it, and that's 25. And 25 times 3 will get us back to 75. So now bring down your 6. You're going to multiply by what you get by taking the square root of 25. Square root of 25 gives us 5. That comes out in front, gets multiplied by the 6, and inside the radical, we're left with a 3. So our final answer is 30 square root of 3. All right, on number 3, notice it's a multiplication problem. So we're actually going to multiply the numbers that are out in front, 5 and 2, and then inside the square root, we're going to multiply the 10 and the 15. So you multiply the numbers on the outside together, multiply the numbers on the inside together. All right, that's going to give us 10 times the square root of 150. But we're not done yet because what's inside that square root can now be simplified. So you have 10 times whatever we get when we simplify the square root of 150. Now 150 is also a number that's divisible by 25, just like on question number 2, we could divide 75 by 25. And 150 divided by 25 leaves us with 6. I always circle the number that we're going to take the square root of. So take the square root of 25, and we get 5. So it gets multiplied by this 10 that's out in front. And what we're left with inside the square root is 6. So final answer is 50 square root of 6. Remember, we're looking for a square root in simplest form, no decimals here. And number 4, we can't subtract just yet because these two radicals are not like terms. So we need to simplify them both. So keep that 8. The square root of 12 would simplify to 4 times 3, 4 being a perfect square. And I'm going to take that one all the way down, like simplify it completely. So we have 8 times 2. That 2 comes from taking the square root of 4. We're left with 3 inside the square root. So we end up with 16 square root of 3. Then we have to go back up and simplify the other square root too. So we have 3 square root of 27. So that 27 factors into 9 times 3. 9 being our perfect square. So we're subtracting. We have a 3 out in front. And it's going to be multiplied by another 3 because the square root of 9 gives us 3. And then we're left with this 3 inside the square root. So negative 3 times 3 is negative 9 square root of 3. And now we have like radicals. So we have 16 square root of 3 minus 9 square root of 3. 16 minus 9 gives us 7 square root of 3. Final answer. Okay, on 5 and 6, the directions say find the missing side lengths of each triangle. Leave your answer in the simplest radical form. So no decimals for this particular one, or these two problems. All right, so I wrote a couple notes here. We're going to use Pythagorean theorem, and that's because these two are right triangles. Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So in number 5, we'd set it up as 6 squared plus 12 squared is equal to x squared. So the side opposite that right angle is your hypotenuse, and it's always going to stand alone. Okay, so do the math. 6 squared is 36, 12 squared is 144, and that's equal to x squared. Combine those two together. 36 plus 144 is 180 equals x squared. And then we want to take the square root of both sides. The square root of x squared gives us x, but on the other side, the square root of 180 has to be simplified. Now I know it's even, so 4 most likely will divide into 180, but we want to go bigger than that. The largest perfect square that divides into 180 is actually 36. So you get 36 times 5. Square root of 36 gives us 6 on the outside. We're left with 5 on the inside. So x is equal to 6 square root of 5. Okay, one more of this type. This time, x isn't on the hypotenuse. It's on one of the legs. So we're going to set it up as x squared plus 12 squared is equal to 14 squared, because 14 is the hypotenuse. So we'll have x squared plus 144 is equal to 196. You want to take and subtract 144 from both sides. And 196 minus 144 leaves us with 52. So right now we've got x squared equals 52. Take the square root of both sides. The square root of x squared just gives us x. Now with the square root of 52, it's even. So if we try dividing by 4, we end up with 4 times 13. So 4 is our perfect square. Take the square root of it, and we do get 2 square root of 13. That's your final answer. Okay, in 7 and 8, it says, given that each set of numbers are the sides of a triangle, tell whether the triangle is acute, right, or obtuse. So we have 3 different types of triangles, and I put this little chart over here to the right, and this is available, available to you on your toolbox for this unit. You can use that as a reference sheet as you're going through the review and the test. Okay, so c squared is exactly equal to a squared plus b squared. You have a right triangle. If c squared ends up being larger than a squared plus b squared, it's obtuse. And then finally, if c squared is smaller than the sum of a squared and b squared, it's an acute triangle. Okay, well, first thing you have to do is identify what A, B, and C are. You don't have to worry about A and B so much, but C is always going to be the largest number. Because if it is a right triangle, C would be the hypotenuse. Okay, so we are going to take a look here, plugging these numbers in. So I want to put 8 squared, and I'm just going to set it equal to 6 squared plus 6 squared. All right, so we might have to change that sign later on to greater than or less than. So 8 squared is 64. On the other side, 6 squared is 36. So we have 36 plus 36. On the left, we have 64, but now on the right, we have 72 for that total. And 64 is definitely less than 72. So that says c squared is less than a squared plus b squared. And in our chart, that's the last scenario. So this would be an acute triangle. So the sides 6, 6, and 8, if you put them all together, it would make a triangle where all the angles are less than 90 degrees. And number 8, we want to compare 11 squared to the sum of 6 squared and 8 squared. 11 squared is 121, 6 squared is 36, 8 squared is 64. So we have 121, and we're comparing it to just 100 on this side. So this time around, we have 121 is greater than 100, or c squared is greater than a squared plus b squared. And that's going to be the second case. So these would be the sides of an obtuse triangle. And number 9, it asks us to find the exact values of x and y in the triangle below then to find the area of the triangle. So there are three answers that we have to give for this one. All right, first, solving for x, we have to use the Pythagorean theorem because this triangle on the right is a little right triangle. So we do x squared plus 5 squared equals 13 squared. So we'd have x squared plus 25 equals 169. Take and subtract 25 from both sides, and we end up with x squared is equal to 144. And this one works out nicely. We're going to take the square root of both sides, and the square root of 144 gives us 12. Okay, so I'm just going to come in and erase that h right there and put 12 on that side. All right, 12 is the height. So right now, solving for the area, we don't know the base yet, but we just calculated the height to be 12. Okay, next, we want to take a look at this triangle on the left. All right, we have to solve for y next. So solving for y, we're going to use Pythagorean theorem. We'll do y squared plus 12 squared equals 15 squared. So we have y squared plus 144 is equal to 225. Well, if you take and subtract 144 from both sides, it's going to go to 0 here, so you have y squared. And on the other side, we just end up with 81. All right, to solve completely for y, take the square root of both sides, and the square root of 81 will give us 9. Okay, so the base isn't equal to 9, but the base is equal to the sum of 9 and 5, or 14. Okay, plug that in your area formula. So area equals 1/2 of 14 times 12. You can take half of 14 and multiply it by 12. I did 14 times 12 first and got 168, and then I took half of that. And half of 168 gives us 84. And it's an area, so it would be good to write square units on your final answer. All right, and number 10 might help if you draw a picture. And it says we have a rectangle with a width of 9 centimeters and a diagonal 16 centimeters long. And we're being asked to find the length in exact form. So we're solving for this side, which I'll just label with an X. Okay, one thing to notice is that when you draw in a diagonal of a rectangle, you create two right triangles. So if we have a right triangle, then we can use Pythagorean theorem. So we can set it up as x squared plus 9 squared equals 16 squared. So you have x squared plus 81 is equal to 256. Okay, we're going to subtract 81 from both sides, and we end up with x squared is equal to 175. Okay, notice that the directions say find the length in exact form, and in parentheses I wrote a little reminder. That means simplest radical form. So we want to take the square root of both sides and simplify. So we end up with x squared. And 175, just like we've seen in the previous questions, like 75 and 150, 175 is another number that's divisible by 25. Just think about if you had $1.75, how many quarters that would be. And that's 7 quarters. So 25 times 7 gets us back to 175. Take the square root of 25, we get 5. We're left with 7 inside the square root. And we're going to put centimeters on there. So the length of our rectangle is 5 square root of 7 centimeters. Really exact length, no rounding. Okay, number 11 should be really quick if you're thinking of special right triangles and you have the examples of our 2 special right triangles on your toolbox sheet. Notice that these 2 sides are marked congruent to each other. So I'm going to label this side with 6. And then we have a triangle where a right triangle where the 2 legs are equal to each other. That's a 45-45 right triangle. So when this happens, each of these legs would be x and x. Hypotenuse would be x squared root of 2. So we're going to take our leg, 6, and multiply by the square root of 2 for that hypotenuse. The x is representing this angle right here, and it would be 45 degrees. So final answer is x is equal to 45 degrees, because it's the angle, and y is equal to 6 square root of 2. And that's it. Okay, in questions 12 through 15, we're going to be using trig, sine, cosine, and tangent to solve for the missing side. So first, label your angle. I got 62 degrees, so go across the triangle to get to x. X has to be labeled as opposite, and 13 is not the hypotenuse, so it must be the adjacent. Opposite and adjacent is going to lead us to the tangent function. And again, you have your reference sheet, you have your notes, so you can have everything in front of you when you're working on the review and the test. So you have tangent of 62 degrees equals x divided by 13. Right. I like to put tangent of 62 over 1 just to help you realize that it is a proportion, and we'll cross multiply. X times 1 gives us x, and that's equal to 13 tangent of 62. Right, you're going to go to your calculator next, whether you're using scientific calculator, the Desmos scientific calculator, whatever works for you, and then we're going to round to the nearest tenth. So our final answer would be 24.4. Okay, number 13, again, similar setup. 48 is our angle, 12 is our opposite side, and x is our adjacent side. So we're going to stick with tangent. So tangent of 48 is equal to 12 over x. Okay, this is one of the ones that's a little bit trickier, and that's because when we cross multiply, we don't get x alone. We end up with x tangent of 48 equals 12. So when the variable's in the denominator, it takes us 2 steps to solve for x. So divide by the tangent of 48 on both sides. These will divide out. You've got x is equal to 12 divided by the tangent of 48. And now you're ready to go to your calculator. So 12 divided by tangent of 48 ends up being 10.8 when you round to the nearest tenth. Okay, in 14 and 15, we have 2 more that we're going to use trig on to solve for missing side. So 75 degrees is our angle. So I go all the way across the triangle to get to x. That's got to be our opposite side. And this time around we have the hypotenuse. 14 is our hypotenuse because it's across from our 90-degree angle. Opposite and hypotenuse leads us to sine. So we'd say sine of 75 degrees equals x over 14. All right, put that sine of 75 over 1, and then we can cross multiply. So cross multiply, and we get x by itself. Along the other diagonal, we have 14 times the sine of 75. You're ready to go to the calculator with that, and when you do, when you round it to the nearest tenth, it should be 13.5. Okay, one more where we're solving for sides. So our angle is 68 degrees. This is the adjacent side. So 12 is adjacent and x is the hypotenuse. All right, so adjacent and hypotenuse leads us to cosine. So we have to be taking the cosine of an angle. So cosine of 68 equals 12 over x. Okay, notice that x is in the denominator. So this one will take us 2 steps to get x alone. When we cross multiply, we end up with x cosine of 68 equals 12. And then we need to take and divide both sides by the cosine of 68. Okay, so we have x alone now. This is what you'll type on your calculator, and when you do, it ends up being 32.0 if you're rounding to the nearest tenth. So that's your final answer. Okay, in 16 and 17, we're still using trig. We will be for the rest of the review. But in 16 and 17, we're trying to solve for the missing angle. You still go through and label your sides. So across from x, I see 10, so that's the opposite side. And 14 is adjacent. Right? It's so important to label the sides because that is what tells you which trig function to use. Opposite and adjacent leads us to tangent. And this time we're going to write tangent of x because the angle is what we are looking for. Tangent of x is equal to 10 over 14. Whenever you're solving for an angle, you totally want to rewrite your equation. And we want to rewrite it using inverse tangent, or what we call tan negative 1. Okay? So we're going to rewrite it as x is equal to tan negative 1 of 10 divided by 14. And when we do that, go to your calculator and type it in, and we end up with 36 degrees. Remember, with angle measures, we round to the nearest whole degree, so whole number. All right, in number 17, I have 6 is the opposite side to my angle x, and 10 is the hypotenuse. All right, so 10, opposite over hypotenuse leads us to sine. So we're going to say sine of x equals 6 over 10, and then rewrite using inverse sine. So we're going to rewrite it as x is equal to sine negative 1, 6 divided by 10. And now you're ready for your calculator. And when you do that, we end up with 37 degrees. Final answer. Okay, for the last 3 questions, we are going to be drawing a picture, but still using trig to solve it. All right, we want to round our answers to the nearest tenth in every case. All right. Okay, from the top of a lighthouse, 18 meters high, so that line is going to represent my lighthouse. And I'm going to put those units there. It says the angle of depression to a boat is 4 degrees. So if you were at the top of that lighthouse, like on the observation deck, and you looked out towards the horizon, and then looked down towards the water, and this little boat caught your eye, that angle right there would be 4 degrees. Just remember that this is not the angle of depression inside the triangle, okay? Now, the question is, what is the distance between the boat and the base of the lighthouse? The base of the lighthouse is the bottom, all right? So we want to find this distance between the base and the boat. All right, we're going to assume that the lighthouse is standing up nice and straight, so it's perpendicular to the water level. And so we're going to be working with this right triangle right here. Okay, but if you notice right now in that triangle, here's what it looks like. We've got x and we've got 18, but we don't have an angle in there. And if you recall from our lesson on applications, the angle of depression from that person's perspective up high would be equal to the angle of elevation from a person down below on the boat. So we're going to put that 4 degrees right down in that lower right-hand corner. So it's a really small angle, okay? For that angle of 4 degrees, the height of the lighthouse is the opposite side, and the distance along the water is the adjacent side, right? We don't know the hypotenuse, we don't have to find the hypotenuse. Opposite and adjacent leads us to tangent. So we can say the tangent of 4 degrees is equal to 18 over x. Okay, notice that x is in the denominator, so it's going to take us 2 steps to get x alone. Cross multiply, we get x times the tangent of 4 is equal to 18 times 1, which is 18. And now take and divide both sides by the tangent of 4. Okay, these will divide out. This is what you type into your calculator. And we end up with 257.4 meters. Okay, number 19, it says a kite is flying at an angle of elevation of about 40 degrees. So here's your kite up in the air. That's the little tail on the kite. All right, so angle of elevation would be this angle right here. So put 40 down below. It says all 80 meters of string have been let out. Well, this is your string of your kite. So 80 meters for that side. And we want to find the height of the kite. So we're looking for how high in the air it is. And that's going to be perpendicular to the ground right here. Okay, so that 40 degrees going across the triangle, the height of the kite would be the opposite side. And this is our hypotenuse. The string is the hypotenuse of our triangle. So opposite and hypotenuse leads us to sine. So we're going to say sine of 40 is equal to x divided by 80. All right, cross multiply, we end up with x is equal to 80 sine 40. All right, so that's just a one-step equation to get x alone. And now jump to your calculator, and 80 sine of 40 leads us to 51.4, and it'll be in meters. Okay, our last one, it says a 20-foot ladder is leaning against a house. So you have a house, and we have a ladder leaning up against it. So here's the ground, here's our ladder. Okay, so our ladder is actually forming a hypotenuse of this little right triangle right here. Okay, we're assuming that the house is standing up nice and straight, so it's perpendicular to the ground. All right, it says if the base of the ladder is 8 feet away from the house, the base of the ladder will be the bottom. So this right here is the base of the ladder. And what it's saying is that this distance from the house is 8 feet. And we want to figure out the measure of the angle between the ladder and the ground. So we're looking for this angle right here. All right, the angle up above, up here, would be the angle between the ladder and the house. All right, we're not solving for that one. Okay, so based on where the angle is and the labels on our sides, we have the adjacent side to our angle, and we have the hypotenuse. Adjacent and hypotenuse leads us to cosine. So you're going to say that cosine of x is equal to 8 over 20. And then because we're solving for an angle, we need to rewrite the equation using inverse cosine, or if you want to call it cosine negative 1. All right, so it would be x is equal to cosine negative 1 of 8 divided by 20. And then you're ready for the calculator. Now on this one, I did round to the nearest whole angle because that's usually what we do for angles. So our final answer would be 66 degrees.